morning. My name is Isabella Barger. I am an undergraduate in the Emergency and Disaster Management program here at Western. And I will be presenting research I performed this past fall under the supervision of my advisor, Dr. Jackson. And the title of this presentation is Examining Appalachia's Social Vulnerability to Extreme Flooding Through Its Historical Context and Land Distribution. So just a quick term review before we get into it. Disaster risk is defined within the field as actually an equation of factors, which includes the presence of a natural hazard, the existing vulnerability within a community pre-disaster, as well as the level of exposure to any given event. So disasters occur when natural hazards are combined with the pre-existing vulnerability, and your experience of the disaster depends largely on your exposure to the hazards. Social vulnerability is a concept that was pioneered by Dr. Susan Cutter at the University of South Carolina, and it describes how disaster impacts are experienced disproportionately across communities based on pre-existing conditions that make them more or less prone to experience these adverse impacts. This includes things like race, gender, socioeconomic status, and even type of employment. For the purposes of this project, extreme flooding is defined as a hydrological event that causes significant losses of life and property and warrants a federal disaster declaration. I do want to note super quick that federal disaster declarations are an exclusively economic measure and they do not account directly for fatalities. Although if a federal disaster declaration has been issued, it's incredibly likely that fatalities have occurred during the event. So my two research questions were, what is the scope of social vulnerability in the Appalachian region on a county level of analysis? And is social vulnerability contributing to the increased impacts of extreme flooding within the Appalachian region? My parameters for this study were both spatial and temporal. So for the definition of Appalachia as a region, which I'm sure you know can be highly debated, I used the Appalachian Regional Commission study area. It's one of the broadest definitions. I wanted to make sure that I wasn't missing any counties. But this, again, is an exclusively economic measure and it changes year to year. And for my temporal boundaries, I pulled all federal declarations from 1968 to 2024. I did the study in 2025, so I wanted to make sure I had a full year of research there at the end. And in 1968, the US government set up something called the National Flood Insurance Program. And following the establishment of the NFIP in 1968, reporting of extreme flooding became much more common and uniform since there was a defined criteria for it. In the methodology section, I used rural-urban continuum codes, also called RUC codes. It's an ordinal ranking of population and adjacency to metropolitan areas within a county, used by the US Department of Agriculture. It's ranked 1 through 9. 1 is the most metropolitan, 9 is the most rural. Federal disaster declarations are published by FEMA using their open FEMA database. And from 1968 to 2024, I found about 5,400 federal disaster declarations issued for extreme flooding within the study area. In order to be included in my study, the declaration had to use the words flooding, heavy rain, hurricane, tropical storm, or tropical depression. This is just a quick overview of the RUC codes. So it's ranked not only on the population within the county, but if it's adjacent to a metropolitan area. Just to give you a quick idea of, let me see if I can move this out of the way a little bit. Perfect, okay. So to give you an idea of the study area, we start from the very southern end of New York and we go all the way down to northern Mississippi and Alabama. Like I said, this is the ARC definition. If you asked most people within Appalachia to draw a map of what they thought the region looked like, this probably wouldn't be it. And here you can see the distribution of RUC codes within the region. So these dark areas down here in 8 and 9 are our most rural counties, while these lighter areas are either metropolitan or adjacent to a metropolitan area, which you can kind of see if you look at Buncombe County, which is up near the urban end of the RUC codes, and the counties around it are also lighter in color because they're adjacent to Buncombe County. Continuing with our methodology, The Social Vulnerability Index, also called a SOVI, was developed in the Hazards, Vulnerability, and Resilience Institute at the University of South Carolina. It uses 29 census-derived variables, z-score standardization, and principal component analysis to create a quantitative measure of social vulnerability. These 29 factors that we pull from census or American Community Survey data include a wide variety of factors like race, gender, socioeconomic status, type of employment, such as employment in an extractive industry or a service industry, type of housing, housing burden, and a wide variety of other things. It's also important to note that when you see a SOVI score, which you'll see in the next couple of slides, that they are mapped as a comparison within the area. It is not a value that can be transferable outside of the study area. So in order to have the most up-to-date data, I used the 2023 American Community Survey estimates, which included 423 counties within the study area, as well as 7 independent cities, because the state of Virginia excludes its metropolitan cities from the surrounding county. And overall, a higher SOVI score indicates a greater vulnerability to environmental hazards. So what we can see here is just the SOVI scores mapped, and these high areas are where the greatest vulnerability is existing. So you can see our pockets here in eastern Kentucky, West Virginia, and western North Carolina. And these areas in the blue have a lower overall vulnerability and are thought of to be more resilient towards these impacts, which you can see here in Alabama and most of Pennsylvania, as well as Ohio. This is the factor table for SOVI. So when the variance is explained, it groups them into your top factors that explain your variance. And so what loaded most strongly for this particular SOVI was poverty and elderly populations, both of which massively contribute to social vulnerability. And the poverty and elderly factors were true across most of the study area. I also want to highlight factor 7 down here, race, Native American, and service industry. This factor is very hyper-localized to western North Carolina, where vulnerability down in our area can be attributed to people employed within the service industry, as well as the Eastern Band of Cherokee. So for this particular SOVI, 76.6% of variance was explained by the 8 significant factors that we just saw. The 3 most vulnerable counties were all RUC 9s, which are a population of 5,000 or less non-adjacent to an urban area. And these were Holmes County, Ohio, Swain County, North Carolina, and Wolfe County, Kentucky. Our highest concentrations were in Eastern Kentucky, West Virginia, and Western North Carolina for vulnerability. And the lowest concentrations were in Ohio, Pennsylvania, those 3 counties at the very edge of Maryland, Alabama, and Mississippi. This is a bivariate map. It lets us map 2 different study factors at one time. And so in this map, you are looking at RUC codes mapped against SOVI scores. So our darkest areas up here in the high section of the grid are areas that are both very rural and have higher SOVI scores. And I want you to pay attention to this pocket down here at the very end of western North Carolina, as well as coming back up to West Virginia and eastern Kentucky. This is another bivariate map. It's mapping total disaster declarations against SOVI scores. Disaster declarations were not normalized by population. It's just a raw count per county from 1968 to 2024. So our areas that have these high rates of both disaster declarations and vulnerability actually shifts the western North Carolina pocket up to these very rural counties on the northwestern border, which also happens to be where we saw the highest fatalities per capita during Helene, as well as, once again, coming back to our cluster here in eastern Kentucky and West Virginia. For the variable analysis, I used the Pearson correlation, which gave us a positive relationship between high SOVI scores and federal disaster declarations, indicating that if your county is in a higher level of social vulnerability, you are more likely to have a federal disaster declaration. And the top 10 highest vulnerability scores across the board were all in RUC counties 8 and 9. When I did a thematic analysis of the federal declarations outside of any other factors, I found that the higher percentage of them were actually declared for non-tropical systems at 68%, which means that they were localized fronts, training thunderstorms, and smaller systems that moved typically west to east. So our takeaways here is that there's a positive correlation between social vulnerability and the likelihood of federal disaster declarations, that greater social vulnerability exists within our rural communities, which does make up a majority of the study area here in Appalachia, and that more attention and mitigation efforts should be focused on localized non-tropical systems, which are causing the majority of extreme flooding seen in Appalachia. For future research, I'd like to run a spatial correlation testing called a local Morans 1. This pulls in all of the counties and really highlights those clusters that we're seeing and gives them kind of more quantifiable analysis. I'd also like to do a factor by factor analysis with those 8 key components that we saw earlier, where you can see on a more localized level within counties which factor is loading the strongest for that specific county instead of how it looks across the region. And for our hot pockets in eastern Kentucky and West Virginia, as well as western North Carolina, I'd like to drop it down to a census tract level so we can see on a more localized level what that vulnerability is looking like. And just across the board, we are in a little bit of desperate need for increased examination into regional and localized flooding, analyzed separately from tropical systems. Tropical systems can cause massive amounts of damage, but they are far less common in Appalachia than these localized thunderstorms that are causing damage season after season. And that's all I got.